In this video, I will cover about the concept of multi-stage graph problem. Multi-stage graph problem which can be solved using the backward approach, or it can also be solved using the forward approach. And this is a concept which can be solved using the dynamic programming concept. So multi-stage graph, what is actually the multi-stage graph problem? So given certain kind of the graph which contains the vertices, set of the vertices and set of edges. And since we are using the concept of the dynamic programming, it has been partitioned into k greater than or equal to 2 disjoint sets. Given a graph, and this graph is being divided into k stages ranging from stage 1 to the last stage. And u comma v is an edge in E, then u belongs to the Vi, that is, consider u is a vertex that belongs to the stage 1, and v that belongs to the stage I plus 1, that is nothing but the next stage. And c of I comma j be the cost of the edge that is connected from I to j. The cost of a path from the source S to the sink T is the sum of the cost of the edges along the path. And the objective of this multi-stage graph problem, that is a goal, is to find the minimum cost path from the source to the destination vertex. And every path that starts from the source vertex, and it has to go through the various stages, and each stage may contain several number of the vertices, and out of these kinds of the vertices you will be selecting the optimal solution, that is minimum cost. If you recall the concept of the dynamic programming, basically it is the optimization problem. And optimization problem, that is, it may be the maximization problem or it may be the minimization problem. Maximization problems can be given as an example like a 0 or 1 knapsack problem, which can be solved using the dynamic programming to maximize the profit. And when considered multi-stage graph problem, it is the minimization problem, that is, minimum cost path has to be identified using the dynamic programming. And even if you recall the concept of the dynamic programming, it is similar to the divide and conquer. Of course, within the case of the divide and conquer, the concept is being implemented in such a way that the sub-problems are being treated independently. But unlike in the case of the multi-stage graph problem, the solution of a certain kind of the sub-problem, if it is been found and it is the optimal solution, then this kind of the solution to the sub-problem can be used in solving the other kind of the sub-problem which has the same kind of the concept. And similarly, there are two criteria which are being involved in the multi-stage, dynamic programming, that is overlapping subproblems and optimal substructure, that has been discussed in the previous video. And there are two approaches where we can solve the multi-stage graph problem, that is forward approach and as well as the backward approach. And coming to the forward approach, that is here we are assuming like there are k number of the stages. What is a stage and how to identify the stage, that will be discussed with an example. And starting from the last stage and start from the last stage and find out the cost of each and every vertex to the first stage. So within the forward approach or within the backward approach, there are two parameters, that is cost and as well as the path. So in the forward approach, it is in the reverse order. That is, if it is a forward approach, then the cost is being identified in the reverse order, that is from the last stage to the first stage. And whereas in the backward approach, that is within the case of the backward approach, the cost can be identified or cost has to be calculated starting from the first stage till the last stage. So as I mentioned, there are two approaches, the forward approach and as well as the backward approach. And there are two parameters which are being associated, that is cost and as well as the path. When you need to find the cost using the forward approach, just give an hint like it is from last stage to the first stage. You need to calculate the cost from the last stage to the first stage. And when coming to the backward, that is, you need to start from the first stage to the last stage in order to find the cost. And coming to the path, so the path in the forward approach, it is from the source vertex to the destination vertex. And whereas within the case of the backward approach, it is from the destination vertex to the start vertex. And here you can observe there are two formulas which are being implemented in the multi-stage graph problem depending upon the approach that you are using. In the forward approach, that is cost of I comma j, that is how to calculate the cost. So cost of I comma j is given as minimum of C of j comma L plus cost of I plus 1 comma L, and where L belongs to the Vi plus 1, j comma L belongs to the set of the edges, that is E. And the backward approach, that is here there are, even in the backward approach, there are k stages, and you should also find the cost and as well as the path. Unlike in the forward approach, we have found the cost, or we will be finding the cost from the last stage to the first stage. And in the backward approach, you have to find the cost from the first stage to the last stage. And to find the minimum cost path from the destination to the source, that is from stage k to stage 1. And the formula that is been associated with the backward approach is b cost of I comma j is given as minimum of b cost of I minus 1 comma L plus C of L comma j, where L belongs to the vertex Vi minus 1 and L comma j is an edge that belongs to the edge, that is capital E. And even I have explained about what is this I, what is this j, what is this L, and so on. So coming to the I indicates the stage. So I indicates the stage where you are, and similarly j indicates the vertices that are present on that particular stage. Like take for example, at stage 3, that is consider at stage 3, there are something like vertices, something like V4, V5, and similarly V6. These are the vertices that are present at stage 3. So I becomes 3, that is stage. There are various stages. Consider a given graph contains stage 1, stage 2, stage 3, and so on till stage k. And we are considering at a certain stage, that is at something like stage 3. At stage 3, if you consider the vertices which are present, that is V4, V5, and similarly V6. So here I value becomes 3, that is stage at the stage I equal to 3, indicates the stage 3. And j value will be V4, and similarly j value will be V5, and similarly V6. So these are the vertices which are present at stage I, that is at stage 3. And from this vertex, that is like take for example here it is been connected to something like a V2, and this has been connected to something like V1, consider. And similarly there are certain edges which are being connected over to this scenario. So how can you understand regarding the backward approach is, here there are certain, it is a directed graph where the directions are being provided to this vertex, that is vertex 4. So when you take vertex 4, then it is being connected from V1, and similarly this vertex is also being connected from V2. That is for V4 there are two vertices which are being connected, that is edge. V2 to V4 edge exist, and V1 to V4 edge exist. So here the values of your L will be equal to, that is V2 and similarly V1. This is what you need to understand before going into details about the backward approach. And within the given graph, like take for example here the graph has been given, that is starting from there are n equal to, that is 12, indicates 12 vertices are present within the given graph. And here also you can observe certain stages. That is, this is your stage 1, stage 2, stage 3, and so on, stage 4, and similarly stage 5. These are the stages, and your source vertex to be equal to 1 and the destination vertex to be equal to, that is 12, or n equal to 12. These are the assumptions, I mean these are the initial values that has to be known related to the multi-stage graph problem. And the first thing, if you recall about the forward approach, so within the case of the forward approach, you should find the cost and as well as you should find the path. So cost is in the forward approach, it is from last stage to the first stage, and whereas path is from the source to the destination. That is related to your forward approach. And coming to the backward approach, that is within the backward approach, you need to find the cost as well as the path. So within the backward approach, you should also find the cost and you should also find the path. When considering the cost, so cost is from first stage. You need to find the cost from first stage and go to the last stage. Similarly, the path is from the reverse, I mean from the destination to the source vertex. That is what I have explained about the backward approach. So the first thing that you have to do within the backward approach is you need to find the cost. As I mentioned, it has to be started from the first stage. So at your stage 1, of course, the formula is been given to find the cost, that is b cost of I comma j equal to min of b cost of I minus 1 comma l plus cost of l comma j. So you need to find the cost at stage 1. So here the stage 1 cost has to be identified. That is cost of, and I mean b cost, because we are using the b cost, that is backward cost. So b cost of I comma j. I comma j. So what is the value of your I? As I've explained, that is I indicates the stage and j indicates the vertices that are present in stage I. So if you recall about, if you consider this graph, that is you'll be finding b cost of I. What is I? That is stage 1. So b cost of 1 comma, and what is the value of the j? That is j indicates the vertex or vertices that are present at that particular stage. Since there is only one vertex, that is you need to find b cost of 1 comma 1. Similarly, if you need to find the stage 2, of course I'll explain b cost of I minus 1 comma l plus c of l comma j how to find. And coming to the stage 2, so at your stage 2, that is you'll be finding b cost of, what is the stage? Stage is equal to 2, and what are the vertices that are being present? The vertices that are present at your stage 2 is 2, 3, 4, and similarly 5. That is you need to find 4 values. That is b cost of 2 comma 2, b cost of 2 comma 3, b cost of 2 comma 4, and as well as b cost of 2 comma 5 has to be found, has to be computed. Similarly, this process goes on. So consider at stage 3. So at stage 3, that is you need to find b cost of 3 comma, what are the vertices that are present at stage 3? That is 6, 7, and 8. That is 6, 7, and then 8. You have to find the cost of these kinds of the values. Similarly, b cost of, I mean at stage 4. So at the stage 4, that is b cost of I indicates the stage, that is at the 4th stage. What are the vertices that are present? That is b cost of 4 comma 9, you have to identify, I mean compute. B cost of 4 comma 10, because we have the vertices at your stage 4, that is 9, 10, and similarly 11. So you have to compute b cost of 4 comma 11. And at your last stage, that is b cost of, that is stage indicates that is 5. And what is the vertex that is present? The vertex that is present is equal to, that is 12. So b cost of 5 comma 12. This is what you have to identify the cost at every stage: stage 1, stage 2, stage 3, stage 4, and similarly stage 5, because we have totally 5 stages within the given graph. And how to compute b cost of 1 comma 1? Because according to the algorithm of the b cost backward approach, that is, initially b cost of 1 comma 1 is set to 0, unlike in the forward approach. That is, cost of n is given as the 0. That is cost of 5 in your forward approach. That is, we have used cost of 5 comma 12 is equal to 0. This is the initial assumption that is being made. That is b cost of 5 comma 12 in your forward approach. What does this 5 indicates? The stage. And what does the 12 indicates? At the stage 5 there is a vertex that is 12. And in the forward approach, b cost of 5 comma 12 is equal to 0. It is been set. Similarly, within the backward approach, b cost of 1 comma 1, the first stage, first vertex, is been set to 0. And then we have to find what is the b cost of 2 comma 2, 2 comma 3, and so on. At every stage you have to find the cost. So coming to finding the cost of the second stage. So the second stage, which has been given by the formula, that is b cost of 2 comma 2. That is b cost of I comma j equal to min of b cost of I minus 1 comma l plus c of l comma j. So you have to I is provided within your b cost of 2 comma 2. That is, this is your value of your I, and this is the value of the j. So I and j are known, and you have to identify the l values. That is, here if you consider the formula, that is minimum of b cost of I minus 1. What is I? That is 2. 2 minus 1, that will be equal to 1, comma l. We are not aware, as of now we are do not know what is 1. Go for the next one. C of l. L is not known, and whereas j is known, that is 2. So what does this indicates is, here c of I comma j, that is j value is equal to 2. So here if you consider the 2, what are the edges that are being connected to the 2? That is, from there is only one edge. From 1 we can reach to 2, and that will be the value of your the l. That is, l value will be equal to 1. That is, you need to find b cost of 1 comma 1 plus c of 1 comma 2. So b cost of 1 comma 1 already it is been provided from the previous step, and c of 1 to 2. So from 1 to reach to 2, the edge cost is equal to 9. So here the value of your the b cost of 2 comma 2 will be equal to 9. In the similar fashion, you should find b cost of 2 comma 3. How can we obtain? That is minimum of b cost of, what is the value of your I minus 1? 2 minus 1, that will be equal to 1, comma, we shall find out what is this value of your L. And what is the value of your the J according to this case? That is 3. What does this means? J value, consider the J value, that is vertex 3. What are the edges that are being connected to the vertex 3? That is, from 1 we can reach to 3. That is the value of your L. That is, L value will be equal to 1. And find the minimum, what is the cost? That is, b cost of 1 comma 1 is equal to 0 plus c of 1 comma 3, that is 1 to 3, with the cost to be equal to 7. This is how you need to find the cost at every stage. That is, here according to the formula which has been given, you will be finding b cost of 2 comma 2 equal to min of c of I l comma j plus b cost of 1 comma 1. Here you got the value, that is 0 plus 9, that will be equal to 9. Similarly, b cost of 2 comma 3, that is the value of your the L will be equal to 1. What does it mean? The vertex that you have selected, that is 3. That is, this is the value of your I, and this is the value of the J. So consider the here J value is equal to 3. What are the edges that are being connected to 3? There is only one edge, that is from 1. That is the value of your L. And similarly, if you need to find b cost of 2 comma 4, which is been given by min of, replace the value of I, J, and similarly L. How to identify the L? So if you consider the value of here the J to be equal to 4, what is the vertex that has been edge that has been connected to vertex 4? That is vertex 1. So that is what the value of your the L value, b cost of I minus 1 comma L. And similarly, you should also find b cost of 2 comma 5. So b cost of 2 comma 5 equal to min of C of 1 comma 5 plus B cost of 1 comma 1, which will be equal to, of course, it has been given in the reverse order. It should be actually C of 1 to 9, that is 9 plus 0, A plus B or B plus A, it is the same thing. 7 plus 0, 3 plus 0, and similarly 2 plus 0. That will be equal to 9, 7, 3, and similarly 2. So far we have found out at this stage 1, that is the cost is equal to 0. At this stage 2, there are 4 values which are associated to the cost, with the values to be equal to 9, 7, 3, 2. In the same fashion, you should also calculate to the next stage, that is at the stage 3. So at the stage 3, if you consider stage 3, what are the vertices which are being present? That is, at your stage 3, I value becomes 3, and similarly j value becomes, that is 6, 7, 8. So you have to find B cost of 3 comma 6, 3 comma 7, and similarly 3 comma 8. These are the cost which has to be found. So how to identify, how to calculate B cost of 3 comma 6? That is, I value is known, I value is equal to 3, and j value is also known. So j value is equal to 6. So if you consider the 6th vertex, that is at the 6th vertex, at vertex 6, what are the edges that are being connected to 6? That is, from 2 we can reach to 6, from 3 we can reach to 6. So there are 2 parts which are present, C of 2 comma 6 and similarly C of 3 comma 6, and the remaining values are the same thing. Replace B cost of I minus 1 comma L. This is L, do not get confused. This is the value of your L, C of L comma J. So C of 2 comma 6 plus B cost of 2 comma 2, that is, replace the value of your I minus 1 comma L, and the next part is C of 3 comma 6 plus B cost of 2 comma 3. So here you can observe there is C of 2 comma 6 from 2 to 6 with the value to be equal to 4, and B cost of 2 comma 2, that is equal to 9, that is 9 plus 4, that will be equal to 13, and the next part C of 3 to 6, from 3 in order to reach to 6, the edge cost is equal to 2, and B cost of 2 comma 3. In the previous step we found B cost of 2 comma 3 is equal to 7, that is 7. So 9 plus 4, that is 13, and 7 plus 2, that will be equal to 9. The minimum will be equal to 9. In the same fashion, find the B cost of 3 comma 7. That is, from if you consider the vertex 7, what are the edges that are being connected to the 7? The edges that are being connected are, that is 2 to 7, that is 2 to 7, and similarly there is also an edge from 3 to 7, and there is also an edge from, that is 5 to 7. So there will be 3 parts. That is, here if you consider C of 2 comma 7 is the first part, and C of 3 comma 7, and as well as C of 5 comma 7, and replace the remaining values of your B cost of I minus 1 comma L. So what is the cost from 2 to 7? That is 2 to 7. 2 to 7 with the cost to be equal to 2, and B cost of 2 comma 2. B cost of 2 comma 2 is equal to 9. So 9, and C of 3 comma 7. That is edge cost from 3 to 7, that will be equal to 7, that is 7, plus B cost of 2 comma 3, that is equal to 7, and C of 5 comma 7, that is C of 5 comma 7, edge cost from 5 to 7, 5 to 7 with the cost to be equal to 11, and B cost of 2 comma 5. So B cost of 2 comma 5 is equal to 2, that is 11 plus 2. So out of these, that is 11 plus 14 plus 13, the minimum value will be equal to 11. In the same fashion, find B cost of 3 comma 8. Here you get the values like 9 plus 1, that is 10, 14, and similarly 10. There are 2 minimum values that will be discussed in the later part. So here we found B cost of 3 comma 6, 3 comma 7, and as well as 3 comma 8. And after finishing the stage 3, and then we have to compute the cost at the stage 4. So if you consider the stage 4, that is I value will be equal to 4, and the values of your j, that is 9, 10, 11. That is, you need to find, or you need to compute B cost of 4 comma 9, B cost of 4 comma 10, and similarly B cost of 4 comma 11 has to be computed. And if you consider about the 9th vertex, I mean vertex 9, what are the edges that are being connected to the 9? That is, from 6 we can reach to 9, and similarly from 7 we can reach to 9. So there are two edges which are being connected. Those values becomes the values of L. So b cost of 4 comma 9 is equal to, so b cost of 4 comma 9 equal to, since from to 9 we can connect from 6 to 9 as well as 7 to 9. So c of 6 to 9, I mean 6 comma 9, and the next part, that is c of 7 comma 9. Replace the remaining values of your the formula, that is b cost of I minus L, and you find the minimum between, that is 15 and similarly 15. Of course there are two minimum cost, that is 15 comma 15, which will be equal to 15. And then similarly you have to find b cost of 4 comma 10, that is c of to the vertex 10. What are the edges which are being connected to? That is from 6 we can reach to 10, from 7 we can reach to 10, and from 8 we can reach to 10. So there are three parts: c of 6 comma 10, c of 7 comma 10, and c of 8 comma 10, and substitute the remaining values, where you get the minimum values to be equal to, that is between 14 and similarly 15, that is 14 will be the minimum part. And you have to find the next part, that is we have found out b cost of 4 comma 9, b cost of 4 comma 10 is been found, and as well as b cost of 4 comma 11 has to be computed. So look into the vertex 11. So if you look at the vertex 11, from 11 there is only one edge that is been connected. There is only one edge, and the vertex is 8. So there is only one part, that is c of 8 comma 11, plus replace the value of your the I minus 1, that is 4 minus 1, that is equal to 3, and the value of your the L, that is the vertex that has been connected from vertex to the 11, that is 8, that is b cost of 3 comma 8, and where you get the minimum cost, minimum cost to be equal to, that is 16. And after finding the stage 4 cost, you have to find the stage 5 cost, since there is only one vertex that is present at the stage 5. That is, you need to compute b cost of 5 comma 12, which has been given by, that is here if you consider the vertex 12, what are the edges which are being connected? That is from 9 to 12, 10 to 12, and similarly 11 to 12, that is 9, 10, 11. There are three parts: c of 9 to 12, c of 10 to 12, and c of 11 to 12, and then substitute the remaining values of your b cost of I minus 1 comma L, where you get the minimum value to be equal to 16. So here according to the algorithm of the backward approach, you need the cost, that is here in the backward approach you will be finding the cost and as well as the path. Either if you consider the forward approach or the backward approach, you need to find the cost and you need to find the path. So cost is known, cost of 5 comma 12, that is 16, indicates this is the minimum cost with the value to be equal to 16, because we have found b cost of 5 comma 12 is equal to 16. So 16 will be the minimum cost, and then you have to find the path. So path here the same example which I have covered in your previous part related to the forward approach, that is p of 1 is known. So p of 1 is known, that is the first stage, the source vertex is known, and as well as p of the last vertex, last stage vertex is also known. That is, you have to find the path of 1, and similarly p of 2, p of 3, and similarly p of stage 4, and similarly p of stage 5. You have to find the path starting from the stage 1 to the stage 5. So p of 1 is known because there is only one source vertex that will be equal to 1. P of 5 is also known because there is only one vertex that has been present at the destination with the vertex to be equal to 12. So p of 5 is known, and similarly p of 1 is also known. P of 1 equal to 1, and similarly p of 5 is equal to 12 is known. And the next step is you have to find what is the cost at your b cost of 5 comma 12. So at this stage, that is here between the values, that is 5 plus 4, that will be equal to, 15 plus 4, 19, 14 plus 2, that is 16, 16 plus 5, that is equal to 21. So what has led to 16? Which part? That is this part, c of 10 comma 12 plus b cost of 4 comma 10. So that is here led to the minimum cost, that is 16. And what is the value of this kind of your the L? That is nothing but 10. So this 10 has to be included in your P of 4. So now P of 4 will be equal to 10. And the next step that you have to indicate is here according to the next stage, that is if you go back to the other stage, then in such cases here if you observe b cost of 4 comma 10, b cost of 4 comma 10, go back to the b cost of 4 comma 10. So within the case of b cost of 4 comma 10, what is the minimum value? That is here if you consider b cost of 4 comma 10, then what is the minimum value that is present? That is 14 is the minimum. And how did you get this kind of the 14? That is 9 plus 5 14 and 11 plus 3 14. There are two possibilities. That is there are two paths which are available. That is 9 plus 5 14. And what is its respect to part which led to the 14? That is c of 6 comma 10 plus b cost of 3 comma 6. And what is the value of the vertex that is present? That is 6. So there are two parts. The first part I'll explain in this slide, and the next part also we have the 7 that will be discussed in your next part. So here 6 is one of the solution, that is P of 3 is equal to 6. So we have found the path to the at this stage 3 to be equal to 6. And you should also find, that is at your stage 2, that is P of 2. How to find the P of 2? Observe the B cost of 3 comma 6 and find where the B cost of 3 comma 6 is present. And the next part is within your B cost of 6, what are the what led to the minimum value? That is here you can observe that is B cost of 2 comma 2 will be the minimum. I'm sorry, B cost of 3 comma 6, that is B cost of 2 comma 3 has led to the minimum. So consider that kind of the vertex, that is 3 into P of 2. So P of 2 will be equal to 3. So this is your final solution. That is from 1 we can reach to 3, and from 3 we can reach to 6, and from 6 we can reach to 10, and the destination vertex that is equal to 12 with the minimum cost to be equal to 16. This is one of the solution, that is path 1. And in your next path, what does it mean? That is already we are aware about P of 5, P of 1, that is P of 1 equal to 1, P of 5 equal to 5, and similarly at your last stage, that is B cost of 5 comma 12, we have identified what is the minimum and what is its respective vertex, that is 10, P of 4 equal to 10, the same process. And when you consider B cost of 4 comma 10, that is there are here there are two possibilities. What are those two possibilities? That is 9 plus 5 equal to 14, 11 plus 3 equal to 14. In your previous path, that is in your solution 1, we have taken 6 as one of the solution, that is P of 3 equal to 6. Now in this solution 2, that is we take 7. That is P of 3 is equal to 7. So what had here, if you observe B cost of 3 comma 7, then observe what has led the minimum in the B cost of 3 comma 7. So within your B cost of 3 comma 7, the minimum is equal to 11 with the part, that is C of 2 comma 7 plus B cost of 2 comma 2 has led to the minimum. And take that kind of the vertex, that is 2, into the solution, that is P of 2 is equal to 2. And that is how we can get the different solution, with the solution to be equal to 1 to 2, 2 to 7, 7 to 10, and 10 to 12. That indicates there is two paths which leads to the minimum cost that is equal to 16. And that is how we can solve the problem of multi-stage graph problem using the backward approach.